Hello, I'm Mike McCulloch. So today I'd like to talk to you about how quantized inertia predicts gravity and inertial mass. Starting from Heisenberg's uncertainty principle, but this time doing it in a more graphical manner. So Heisenberg's uncertainty principle states that the uncertainty in momentum p times the uncertainty in position x has to be h bar over 2. And this means that anytime a body has a low uncertainty in position, so a small dx, then because the right hand side is constant, the uncertainty in momentum has to increase. So dp has to increase. So these two things are kind of opposites, complementary. So I published a paper back in 2014 and an update in 2016 that derived gravity and inertia in the following way. So graphically, we have the sun on the left hand side, the yellow circle there, and we have a planet which is near to it on the right, and I've shown that as blue. Now, from the point of view of all the Planck masses in the planet, there's a lot of position uncertainty in the direction away from the sun, because they can see incredibly far that direction, all the way out to the cosmic horizon. So I'm going to plot a representation of the size of the uncertainty in position, and as you can see, it's this sort of circle surrounding the planet, which is extending out into space away from the sun. So the uncertainty in position of the planet, or the particles within the planet, is greatest in the direction away from the sun. But because Heisenberg's uncertainty principle applies to all these Planck masses within the planet, then we can say that the uncertainty momentum has got to be the reciprocal of this. So wherever dx is big, delta p has to be small. So we can now draw a dashed shape, which is the inverse of the other one, and you can see that the uncertainty momentum is directed towards the sun, or the other object, and this, as I derived in the papers, looks exactly like gravity, and it's in the right direction too. But that's not the whole story, because as soon as the object, the planet, begins to move inwards towards the sun, then relativity says that information from the direction away from the sun can't catch up with it, so a horizon forms out there, and now that horizon limits the uncertainty in position on that side, whereas the uncertainty in position was large before. Now on that side it shrinks, and so this asymmetry, which had pushed a planet towards the sun, is diminished somewhat, and this behaves exactly like inertial mass, which tends to reduce whatever acceleration you have. So in this way, and I showed all this mathematically in the two papers here, quantized inertia predicts both gravity and inertial mass. And also, for the full picture, you have to consider also the cosmic horizon, which is a symmetrical thing, and when accelerations are very low, that starts to have an effect. But it's quite a neat illustration of it. Okay, so I hope you've enjoyed this short. Please do subscribe to my Patreon channel. Thanks to all those who are already subscribed. It means a lot. And I look forward to making another one of these tomorrow. Goodbye.